Well, now let's take a look at one final rule here for this section, what we call the complement rule. All right, let's take a look here. This says if E represents any event, then E with kind of a little superscript or almost like an exponent of a C, that represents what we would call the complement of E. Now, to kind of understand what we mean by this, sometimes it's helpful to think about probabilities in terms of some pictures. So let's suppose I have something that looks like this. Okay? In here, I could imagine that maybe this represents my sample space. The whole box is my sample space. Everything that could ever happen happens in the box. Well, if E is my little circle down here, then E happens whenever I land inside the circle. E complement ultimately stands for everything else. It's kind of like all the other options is what we refer to as E complement, or the complement of E. And so its formula here becomes pretty easy to see, because I have the probability of E complement should be found by taking 100% and subtracting off this stuff. Or if you take a look over here in the picture, you can kind of see that with a little bit of algebra, this formula also can make a lot of sense. Notice here, the total amount of the box should be 1, because remember the probability of all the stuff is 100%. And notice that if I was to just take my probability of E and add it to the other side, it would say that the probability of E, the red stuff, plus the probability of E complement, the green stuff, should be equal to 1, which is everything. It should make the whole box. And so by just moving that probability of E back to the other side, I get this probability of E complement. Now this can sound really fancy and kind of complex at first, but it's actually an unbelievably simple idea that you probably deal with all the time. Take a look here at example 3 to see how easy of a question this is. According to the National Gambling Impact Study Commission, 52% of Americans have played state lotteries. Okay, 52% of Americans have played state lotteries. What is the probability that a randomly selected American has not played a state lottery? Okay, you may have already come up with the answer. This is really easy. If 52% of people have played the lotto, then what, 48% have not? You got to pick a number that makes it so there's 100% total. Now, if you wanted to go ahead and write this out in a bit more detail, you could say something like this. The probability that a person has not played the lottery should be the same as 100% minus the probability that they have played the lottery. And of course, we know that that's 1 minus 0.52, and so we get 0.48. It's just that simple. So while this sounds like it's a new and fancy rule, it's actually something that's almost extremely intuitive. If 10% of people have done something, 90% have not done it. And so this word here of not is often going to be used as a good indication that we're dealing with a complement. Okay, now there's a lot of rules that are starting to form here. We've seen now 3 rules total in this section. And if you're looking to help try to remember these rules or have them summarized for you in a nice, neat spot, I'd suggest that you go look at the associated exam formula sheet. That is, if you're in Math 225, Business Statistics, I'd ask you to go take a look at the Exam 1 Materials folder. You can find in there an Exam 1 formula sheet. If you're in Math 165, Elementary Statistics, then you could take a look at the Exam 2 Materials folder, and you should be able to find an Exam 2 formula sheet. And these formula sheets will contain all of these different formulas that we're going to be using for exams, and are a great tool, again, for you to use on the exam so that you can quickly and easily access these formulas. I don't care that you have these formulas memorized. That's not the objective. The objective is that you understand how to implement them in a given scenario. And we'll practice that more as we take a look at the next 2 examples.